So this presentation is going to be about clean code, and it's heavily inspired by the book Clean Code, written by Robert C. Martin. Some examples in this presentation is going to be in React and TypeScript, and some in Java. And there are gonna be some maybe some Swedish words and so on in the example, since the code is taken from a Swedish fintech company where I work. The first thing we're gonna take a look at is the DRY principle, don't repeat yourself. And it's basically about not writing the same code twice in different places. This is an example from the company where I work. Here we have 5 instances of using the exact same code line in different places. We are logging an error through our error service. And the interesting thing here is that 4 of 5 of these lines are actually wrong. They have nested if they have a nested function, as you can see here. So there isn't actually gonna be an error logged. We actually had a test to verify that the contact me button would log an error when it failed to execute. But that test were marked skipped, as you can see here, and never run in our continuous deployment setup. So the solution here is to add an optional to the onFailure method, add a default method that in this case doesn't do anything, and to move our error logging inside of the component itself, so we make sure that it will always log when something doesn't work. Next we're going to talk about naming. Naming is actually quite a hard problem in computer software, and it's about communicating with your reader and making things understandable for other people. First we're gonna have a look at these 2 examples. It's about using pronounceable names. As you can see to the left, we have something that I'm not even gonna try to pronounce. It has sort of a technical jargon. It's possible that it's referring to some database specific implementation by naming it data record 1 or 2, when instead we should just name it what it is. It's a customer that contains a generation timestamp, modification timestamp, and a record ID. And here we have some other examples. As you can see to the left, we have a const d, and we have chosen to use a comment to explain what const d represent instead of just naming it what it is. It's elapsed time in days. The second example, date.add 5, that should just be renamed date.increase by days 5 to communicate that we are increasing our date with 5 days. The last example, here we are using a magic number 7, when we should extract it to a constant to name it what it actually is, max classes per student in this case. Extracting magic numbers into constants makes it possible to search for it in your code base, and also use the number in more than one place without having duplicated code. Next we're going to talk about functions. And we are going to go through 3 rules here. The first rule is that functions should be small, and they should never contain more than 20 lines. This means that if you have a large function and it's possible to extract a part of that function into another function with a meaningful name, that is with very high certainty the right thing to do. This will make the code easier to refactor, more easy to read, and it will make it possible to write tests for your code. The second rule is that functions should do one thing, and they should do it well, and they should do it only. Here we have an example. As you can see to the left, we have a method called book that we are passing customer and a Boolean flag into. The Boolean flag is called isPremium, and it will execute two different type of logic depending on if isPremium is true or false. So here you should obviously just extract it into two function and remove that flag. Here is a second example. We have the method checkPassword. And as you can see here, it not only checks the password, but it also initializes the session if it's a valid password. So a quick fix here would probably be to rename the method checkPassword and initialize session, but it would probably be better to just extract session.initialize. And the third rule, low number of arguments. The lower, the better. As you can see to the left, we have a function that makes us return a circle, and it's passing an x coordinate and y coordinates and a radius. And if we take a look at the right side, we have extracted x and y into an object called point, which also symbolizes that the point will be the center of the circle, and thereby making our intent more clear. Next we're going to talk about the Boy Scout rule. This is a very useful rule if you're working in legacy systems, and it's about always leaving your code better than you found it. To illustrate this rule, I have looked at a code base at my workplace. It's a checkout application that contains a very large file called shopping cart. It's 825 lines long, and it contains multiple very long React components. It contains React hooks, it contains some utility functions and other stuff. And it's basically what you see here to the right that this file represents, and you can see the content of the file sort of to the left here, and here you can see that it's a very large file. A very good thing about this file was that it in the end only export a simple shopping cart component that basically rendered a mobile cart or desktop cart depending on your device. When encountering a large file like this, I usually start with trying to extract meaningful components or modules out of that file. So we're going to take a look at how I did that here. The first thing was to extract something that I chose to call basket.tsx, and it's basically the content of this right here. By doing that, we got a 348 lines long component called basket.tsx, placed in its own directory with its own styling as well. It is, of course, a lot more that needs to be done with its components. But the thing about the Boy Scout rule is that you don't have to fix everything at once. Just try to make something better. So we're actually leaving this for the next Boy Scout and moving on to extracting our next component, total price. Total price became a quite small component, which is very nice. And we also were able to take advantage of the dry principle and extract some duplicated logic from mobile cart and desktop chart into total price. So as you can see here, we have moved catalog and basket into total price, and instead of this if statement here and mutating the variable price, we are just calling get total price directly and have added two guard clauses into the get total price function. The last thing that I did in this refactoring was to extract two components, order button and next step button. It's basically two buttons that were placed in the bottom here, depending on where you were in the checkout process. So I placed these two together in a new folder called Step Navigation. And since they share the same styling, they got to share the same styling in their new place as well. So to summarize, we use dry, don't repeat yourself, to avoid having the same code in multiple places. We try to use good naming, both to variable and functions, to ensure that we are communicating in a good way with our reader. And we try to make our function small with few parameters and as little complexity as possible. And at last, the Boy Scout rule, a principle that is very good when you're working with legacy systems and a way to always make sure your code base improves. And that's all from me. Thank you and happy coding.